You heard yesterday about the increasing trend in childhood cancer and childhood leukemia. And I just wanted to put some graphs on it because I think it's easier to register than numbers. Those data are coming from Europe, recent trends that are showing, I guess it's not working, that is showing in different part of Europe, increasing risk of cancers in general, leukemia, lymphoma, other cancers. Of course, there is some regional specificity. You don't see it everywhere, but overall, there is an increase. That was for children aged 0 to 14, and we see kind of a similar trend for adolescents, which, we haven't really talked about this group, and I think that we should definitely move forward and understand a bit more. But we see, again, this general trend of increased risk in most regions in Europe for adolescents. That was another recent paper that was done from a team from the National Cancer Institute looking at other countries than Europe. And again, you see the same trend that is focusing on acute lymphoid leukemia. And you see, in general, an increasing trend over the last 30, 40 years. Now I'm zooming down to California. I'm from California, working at UC Berkeley, and we also worked with the California Cancer Registry to update our own incidence trend for childhood leukemia. And here in the middle, in gray, you see the trend for all the children, regardless of their racial, ethnic background. But what's striking is that the incidence rate of childhood leukemia and the rate of the increase is much higher in Latino children. Latino children represent about 40% of the California population, and this population is increasing. And so there is definitely something going on in this group of children, whether or not this is higher exposure to chemicals or other risk factors or a higher genetic sensitivity. So as we are kind of working with our own data in California, we try to understand why there could be such a differential risk. So we've all learned about what can we learn from those curves that are going in general up? Can we learn about the lifestyle, the environment they are living within, including the parents, any changes in our immune profile and microbiome over the years, any clusters according to social economic status, any issues about characterization of the leukemia and the cancer registry. So I think everybody is aware and wants to understand a little bit better. Are those data going up, fitting some of those trends that are going up? I think this is decent to ask, although some regions are not showing those trends. So part of the complexity also to try to map out those different trends is that the disease is heterogeneous. We're talking about different subtypes. Infant leukemia have a very specific characteristics in terms of molecular signature with the MLL translocation. When we move to children that are up to 14, 15 years old, the majority of the molecular subtypes that we have defined right now, mostly based on the treatment, are a translocation 1221 and high hyperdiploidy. So can we learn from actually the response to treatment that has been showing different effects according to the subtypes? Can we actually learn from the subtypes in terms of the etiologic pathways? So we've tried to look at that as well. And of course, the disease is complex. I'm not asking you to go through every part of this chart, but we talked about residence, where you live matters from, even before conception for the parents to up to the diagnosis. the exposures that you were facing throughout, these life stages do matter, and then you have a lot of components in terms of epigenetics and genetics. So it's hard necessarily to think that it's going to be going from A to B, that it's not going to be an easy answer. It's going to be a complex story to tell when we want to study the risk factors and tell people what we found. So I'm going through the list. You've heard that it may be a déjà vu, and it's kind of a good sequence for me to show show our work here, because you've heard a lot in terms of animal studies that are showing impact. You heard about a lot of biomarkers of exposures, biomarkers of the disease. So all of this is kind of setting the background and a fertile, clues to help showing more evidence towards carcinogenicity. And that may be why, Marco, I was more optimistic, saying there is a body of evidence that can show X, Y, and Z. And others may have a different view on that. I agree that we have our own bias and maybe our own, vision. Immune regulation we have not really touched on that, and I think there will be a talk later this afternoon, but leukemia being a cancer of the blood cells is definitely highly related to immune function. And this is one of the hypotheses that has been quite well characterized, meaning it's kind of the hygiene hypothesis. The more protected the child from the environment, the more likely the child will have leukemia because his immune system is not being primed. I'm not going to really go into that today, but that has been a very strong hypothesis up to now. Fetal growth also, we've talked about what happened in the fetus. This is critical. I'm not going to go through that again. We have found that heavier babies tend to have a higher risk of leukemia. I'm going to be focusing today on more the environmental exposures. And you've heard this list before: smoking, pain, solvent, pesticide, being at home, at work. But I will kind of dive into that a bit more, because we do need to show our findings. We need to really be detailed in what we do so the message can be taken for later prevention. So I'll go over that. And again, other speakers before me have shown you that many of those compounds are known to be carcinogenic agents in adults. So this is not coming out of the blue. What we know a little bit less, that has been less talked about, is that many of them actually are also do have an impact on immune regulation. So, the pathway could be either DNA damage, but they could also work through a more subtle pathway, which is immune regulation. And I will talk about a diet at the end of my talk. So, easy cartoon here to remind people that we saw this graph showing that acute lymphoblastic leukemia has a peak age between 2 to 5 years old. So definitely we are focusing on early years of life, but also pregnancy and preconception. We believe that we have some data that do show that what happens before conception could matter. This is going to be the outline of my talk. I cannot cover everything in details, but I will go over findings we have on pesticide, organic solvent in general, and diet. I would like to guide you to some of methodological issues as I'm showing some of those findings, because yes, we've heard that again. Epidemiology is not an exact science. We try to get as close to the truth, but we know our limitation. But at the same time, this is still very powerful. We're talking about population-based studies. What we've heard before was also very important for us to add substance to the evidence, but it's important to go back to population-based study. We're studying people. So we understand there is some limitation, and we try to kind of counter them. And I will show you some example of methodological issues or studies that we have done to help us understand how robust our findings are. So most of the results that I'm going to show today are coming from two different sources. Yesterday I mentioned the Childhood Leukemia International Consortium, which has its own advantage of bringing a lot of studies together and bring a lot of power in terms of sample, but has other, disadvantage in terms of the precision of the exposure. So this is a give and take. I will also present some of the data that are coming from our California childhood leukemia study, for which we try to infuse a little bit more method studies and work and have more control about the exposure assessment. So I will always balance those, when I can, I will balance those two sources of data. So let's start with pesticide. Again, coming from California, pesticide is a big issue. California produces one of the largest amounts of vegetables for the whole nation and represent a region that has a high exposure to pesticide in general. The majority of the farm workers are from Latino origins, so they are definitely the population that is highly exposed to pesticide in the context of work. And so our study, which covered almost all California, includes, almost all of those regions that have high exposure to pesticide. The way we worked on exposure assessment, we worked with industrial hygienists, occupational epidemiologists, and we developed, we used a questionnaire that was actually developed by NCI, National Cancer Institute, which they call job modules, and we adapted this validated questionnaire to our region to develop a more detailed task-based questionnaire. And the one with the asterisks are showing those are the most frequent occupations that were seen in our population: cleaners, farmers, manufacturers working in manufacturing facilities, and medical workers. So what did we find? Again, we always look at pre and post birth because we're interested in those time windows. We found no association with maternal exposure to pesticide at work and childhood ALL, but we found an excess risk when the father was reporting working in this field. It was in the magnitude of 1.5, 1.6-fold increased risk. When I compare this with the results from the Childhood Leukemia International Consortium, for which we use mostly job titles, and then assign, whether or not the worker was exposed to pesticides, which is kind of, diluting possibly the actual classification, but we kind of found the same, level of association, meaning no association with maternal exposure and ALL, but a 1.2, fold increased risk with paternal exposure. So you can see that there is, it's in the same direction, but it's not in the same, magnitude of association. What we did in our study, because we were able to control a little bit better the source of information, and as I said, we worked from either the job titles, the job exposure metrics that we derived from our job titles, but then we looked at the detailed information from the job modules, and in some instances, the respondents didn't answer all the questions, so we call that partial job modules. We had maybe less confidence. Or the father actually answered the question. And I should say something is that we actually obtained the information from the mother for her exposures and from the father from his exposure. So we didn't have surrogate information most of the time. But you can see that as you increase the precision of your exposure, you actually increase the risk estimate. It's kind of coming from a textbook. We know that if you have a misclassification, you have the potential to dilute your risk estimate. So again, it's going in the same direction, but different level of precision depending on your exposure assessment. So working with our own data, not from the click data, what we found is that those who were reporting to actually apply pesticide and those working on a farm were the ones to have the highest risk of having a child with leukemia. It seems that the risk was higher among those who were diagnosed at a young age, and I think this is what Roberta showed us for pesticide exposure and brain tumor, an interesting analogy. So we also looked at the type of crop that the worker was exposed to. And here we found that the highest risk actually was among those who were working in harvesting nuts. And I don't know if anybody of you has seen what it means to harvest nuts. It's a very, very dirty job. It generates a lot of dust. The amount of pesticides, the type of pesticides are being used for this crop, I think there is maybe 50 different pesticides that are being used to treat nut trees. And the amount of, the production of this type of crop is increasing in California. So this is not a problem that is going to go away. The fathers here who are, working with nut trees and harvesting nuts are highly exposed to dust. And yesterday I talked to you about dust collection in the homes of some of those parents. You can only imagine that, the dust doesn't stop at the door, and that workers are actually bringing dust in their home. We have documented that, and others who are working in the same region as we do have documented that the dust goes in the car, goes in the clothes, and end up in the home. So this is a very important route of exposure that we should definitely try to control as much as possible. We also looked at exposure to pesticide at home, and here I'm presenting data from the CLIC consortium. And here the findings are kind of homogeneous, saying that in general, all things considered, if you look at pesticide, insecticide, pre and post, there is on average 40% increased risk of childhood ALL. We understand that interview are not the best to characterize what type of pesticide, but it seems that the overall impression is that there is an association with home use of pesticide in general. So what can we do with all the issues we have with working with interviews when we want to assess exposure? What we did in our study is that we actually went back and interviewed the parents like 2 or 3 years after their first interview. And just to have a sense of how consistent is the recall between those 2 periods of time. And overall, it was moderate to high, but most importantly, it was the same between cases and control. We always think that there is a differential recall bias, and that may be the case for some exposures, but here for pesticide, it seems that the parent seemed to recall the same way 2 to 3 years apart, in cases and control. So, we may have some, misclassification, but maybe not that much. We went back to the homes and we actually did a visual inventory. We went back to 500 of those homes, and when they said, did you use pesticide, or are you kind of a pesticide user, we actually looked at their, whatever was in their kitchen, in their basement, and we actually collected the information. And we linked this data to the a database that we have available from the Environmental Protection Agency here in the United States to characterize what type of pesticide were there. So we were in general finding it's consistent. Those who are saying they use pesticide, we find pesticide in their homes. And we also find pesticide in the dust. When we went to measure it, there was consistency between self-reports and the amount of pesticide in the dust. And other studies that we have done using geographical information system that we talked earlier before also found some association with pesticide, with proximity to areas where pesticides were used. So again, I'm talking about a constellation of information that tells me maybe the arrow goes there, the compass goes towards, there is a good rationale to believe there is association with pesticide. Other groups have done some selection bias analysis. Now we're concerned about selection bias. The group, Claire Infant-Rivard from Montreal was the one to conduct this analysis. And, she was trying to look at every possible scenario of selection bias, of recall bias, to try to eliminate the association that was seen. And eventually, selection bias could not fully explain the association. So those are approaches that you can do to help provide some level of confidence or not in your findings in general. Temporality, again, we're concerned about asking questions after the fact. I'm going back to the analysis we've done collecting dust in the homes of the family who participate in our study. And just to show that after 2 rounds of collection of dust, we were able to find some, consistency between the two. So those chemicals are not going away that fast. Of course, the ideal scenario for temporality would be to deal with cohort studies, and I've been talking about case control study up to now. It was interesting to look at an earlier study now, 14 years ago. It's a study that is, I think, done by a team at the National Cancer Institute, and they're following workers and cancers in the workers. But now at that time, they had enough follow-up to actually look at the children. And, we're talking about small numbers, but now we're talking about prospectively, and the way they assess, I think, the exposure to pesticide, it's using a diary, so, you hope you have a better idea of what's being used. And at that time, based on small numbers, they found an increased risk of developing cancer in general in the offspring, and the highest risk was Hodgkin's lymphoma. I would love to know when they are going to update this. We are 18 years after that first study, and I think that would be really interesting. And yesterday, scientist from IARC mentioned that he's involved with work from the International Childhood Cancer Cohort Consortium, which is an attempt to bring together cohort studies that didn't really originally had planned to study childhood cancer, but by bringing those together, they hope to be able to answer some questions from a different angle. So at that time, they have about 535 cases of childhood cancers, when the CLIC consortium has 40,000, as I showed yesterday. So they're dealing with their own issues. But it seems that the preliminary findings that were shown yesterday was also, in support of an association with occupational parental exposure to pesticide and increased risk of childhood ALL. So overall, I think this is quite a compelling set of findings to tell us that there is a good evidence that there is an association between pesticide and childhood ALL. I'm going to turn my attention now to organic solvent and polycyclic aromatic hydrocarbon mixture. We talked about mixture earlier today, and I'm not sure I'm going to be really addressing that today. But I want to show you what we have right now. And I will start with benzene. We know that benzene is a well-established carcinogenic agent. We know that it causes acute myeloid leukemia in adults. So there are good reasons to look at benzene and to see what epidemiologic studies can tell us. This was a meta-analysis from a group at UC Berkeley who kind of look at a broad picture using different studies that have looked at exposure that could include benzene from different sources. So it's, it's a broad stroke of trying to look at the cumulative impact of those different opportunities of exposures. And what they found is that here in red at the bottom, the overall pooled odd ratio was 2-fold increased risk. of childhood leukemia. And I think there's a mix of ALL, AML, but the progenitor of those different subtypes could just be, damaged eventually. So I don't think we should just focus on AML. But twofold increased risk in a very, very broad stroke, I would say, broad stroke analysis. But what did we find? We used the same approach from the job modules. I described the data on pesticide, but now I'm going to talk about what the industrial hygienists had classified for us as a different organic solvent. And what we found is that fathers who were exposed to benzene had a twofold increased risk to have a child with childhood leukemia. Interesting. I don't want to make too much of a jump in terms of analogy, but here we still find an association. We also found association with chlorinated hydrocarbons, a 2.5-fold increased risk. And again, those compounds are known to be carcinogenic. TCE is a well-known carcinogenic agent. So this is showing that we should, epidemiologic studies can tell you when they're backed up by toxicology, findings as well. And combustion exhausts also had an increased risk of childhood ALL, and we've been talking about air pollution. So again, this is, an analogy to what has been done before. What I would like to point out, however, is that those associations in our California study was seen only among Latino fathers. There was no association with all this long list of exposures among white fathers. So that brings a lot of question in terms of the condition in which some workers are working. And I don't think we can really assess the level of protection that some of those workers, were using. Is it a higher level of exposure? Is it a higher sensitivity to those chemicals? I don't know, but this was striking. This was striking that the association was much higher among Latino children. And remember, in California, we have a much higher risk of childhood leukemia in Latino children. So something to care about. If we have to target a population of workers, that would definitely be this population. So now I'm going back to use of paint and solvent at home. I'm leaving the occupational, setting. And working with the CLIC consortium, we looked at a different time window of exposure here from before conception, during pregnancy, and after birth. And it seems here that the highest risk for reporting use of any paint was seen when the exposure occurred during pregnancy, with almost a 4-fold increased risk. And here we're talking about like almost 2,000 cases. This is not short, small numbers. But we find association mostly during pregnancy. We had information on what type of paint, and again, here I'm acknowledging the fact that interviews will not tell you exactly what compounds were in the paint, but we looked at those who reported using water-based paint versus oil-based paint, which is more likely to include organic solvent and carcinogenic agent. And the association was mostly seen around, for those oil paint-based exposure. We also looked at professional painting as a broad surrogate of maybe the dose, thinking that if a professional came in the house, maybe more rooms were being painted. This is definitely a not accurate representation, but we found that increased risk was also pretty high when the painting was done by a professional versus the parents. I mentioned to you earlier that at least in our group and few groups in the CLIC consortium have tried to look to look at the risk according to very specific molecular subtype. And we believe that, those leukemia with translocation are very different than leukemia with extra numbers of chromosomes. So for those studies that had this type of data, we actually, looked at these subtypes, and here we find that the increased risk is most likely seen in those children with leukemia that have translocation, like this one is the 1221 translocation, the most common, or the MML rearrangement, which is seen mostly in infant leukemia. So it seems that there is some differential risk depending on the molecular subtype of the disease. I am turning now to solvent. We ask also a question about use of solvent in addition to paint. And here the story was flipped. There was no association with childhood ALL, but there was association with childhood AML. And again, the risk was seen in those who had a characterization of translocation or deletion. So kind of the same trend showing that there is some subtype specificity. Now I'm turning to maternal smoking and paternal smoking, but let's start with maternal smoking. It has been quite puzzling with all the studies that have been done up to date that when we look at maternal smoking during pregnancy in general, the majority of studies have not found any association with childhood leukemia. So a lot of questions are around that, whether it's a recall bias because it's quite taboo to mention that you were smoking during pregnancy, but things have changed over time. So maybe 30 years ago, 40 years ago, it was not. I remember going out, I was a medical student, and I could see women who were almost getting their baby and they were smoking in the hallway. So back then maybe that was not a taboo issue, but in other countries it could. So I will take that argument. It could also be an issue about competitive risk. We know that smoking could induce stillbirth or abortion. So, who knows? Maybe those children who are born from a mother who is smoking have some kind of resistance. I don't know if they kind of survive that. So, there's a lot of issue that we can talk about in terms of having null findings with such a potent carcinogenic mixture, which is tobacco smoke. What our team did is that, again, we wanted to understand maybe better if there was some subtype specificity, and we characterized our childhood leukemia in terms of having RAS mutation or not. And previous studies have found that carcinogenic agent could actually induce RAS mutation, so we were kind of coming from this hypothesis, but we didn't find any association with RAS mutation leukemia. However, when we looked at other subtype characteristics in our group, we found that there was an association with maternal smoking during pregnancy with those leukemia that had high numbers of deletion. So again, we should maybe be careful and not make a conclusion when we're looking globally, when there is some subtype specificity. I'm turning to maternal smoking and AML. Again, smoking is a risk factor of adult AML. So we looked at this in the context of the CLIC consortium, again, because we have larger numbers. And that was based on, I think, maybe 1,200 cases of AML. And same story, when you look overall, there is pretty much no association. The risk estimate is close to 1, no increased risk with AML. What we did, because of the consortium, we had a large group of women coming from Latin America, from Mexico, and actually Brian Manuel is here today. He was participating to our study, but also because of our California study and the study from Washington State, we had a large percentage of women from Latino descent. And here, for those women, we did find an association. That was the first time that this kind of overall analysis was identifying an increased risk of childhood ALL following smoking during pregnancy. Again, are we talking about different genetic sensitivity? Are we talking about maybe different reporting where it's not taboo to mention you smoking? I don't know what explains this difference, but that was something we could do through the consortium because we had enough data. So now I'm turning back to the father. The story for the mother is complex. It's yes, but, or no, but. But for paternal smoking, the studies have been more consistent, showing in general that if a father was reporting smoking at any time before conception and after birth, that there is an increased risk of childhood ALL. And this is coming from a meta-analysis that didn't really bring together the dose data, but was showing for each study that in general there was an increased risk, the risk was higher with a higher level of smoking for paternal smoking at any time. In our study in California, what I would like to say is that it's very difficult to assess pre- and post-natal exposure in situations where actually there is no difference. And fathers may not change their smoking habits in a lot of countries, so you cannot really say it was before, it was after. But in California, we were actually able to identify a group of fathers that had changed their smoking habits. And again, in light of the possible two-hit hypothesis for the development of childhood leukemia, meaning some of those exposure have to happen before birth and then the second hit is after birth, we wanted to look at those two time windows separately. And we could do this in California, and what it shows is that fathers who were reporting smoking only during pregnancy and stopped after birth, and the reverse, those children who were exposed after birth but not before pregnancy, it's only when the smoking was throughout those two time periods that we could see an increased risk of childhood ALL. And we looked at those two major subtypes, and again, translocation 1221 is the one that is coming out in terms of being associated with tobacco smoke. That was the same subtype that we saw with paint before, and to some extent solvent as well for AML. So there's something going on here with translocation 1221 and exposure to mixture of organic solvent in general. We also work with childhood, the key consortium to look at paternal exposure to AML, and we find a 50% increased risk. And again, we had a nice dose response, meaning the heavier the smoker, the higher the risk. And we like to see dose response as much as possible. That helps us to feel some, level of confidence. But this is what we also identified for AML. So I'm going back to our issue in terms of methods. I would like to bring back some of the analysis that was done previously to show that we can actually identify biomarkers of smoking using epigenetic studies. And we actually were able to correlate those validated CPG sites with smoking with our own questionnaire data. So again, we go back to recall. Maybe recall is not that bad because we actually validated our own questionnaire with those CPG sites. So that gives us some level of confidence that maybe it's not that bad. On a side note, having those subtype specificity also goes against strong recall bias. Why a parent would report differently depending on the type of leukemia that the child was diagnosed with. So there is a lot of clues that tell us that maybe self-report is not that bad and we can still work with that. What I would like to also mention is that we had measured dust we had measured PHS in the dust, and we have increased risk of childhood ALL as well. So using different media kind of come up to the same conclusion. Overall, we are in the process of doing some attributable risk analysis, and we're not, we have not finalized the data yet, but working from air pollution data that Marco presented and working from paint, exposure to paint and solvent and tobacco smoke, we estimate that should children or parents not exposed to those agents, it would represent a decrease in 20 to 30% of childhood leukemia could be avoided. I don't know if you notice when you read the literature, the introduction of every paper is we don't know what caused leukemia. We know that only 10% is due by X, Y, and Z. I think it's time to change the story. We know much more than that, and we should readjust our numbers when we present our data to the public. I'm going to quickly present something on the diet. I have 2 slides. This is really important because I talked about what can increase leukemia, but we have found that a diet actually can help decrease the risk of childhood leukemia, mostly looking at folate and B vitamins that are really critical to the DNA synthesis and maintenance. What we have done in the CLIC consortium is pulling data on prenatal folate and vitamin supplementation. I showed those slides yesterday, but for those who were not here yesterday, we found that there's an overall decreased risk of childhood ALL and AML when the mother was taking vitamins and folate supplementation, but that the benefits of this supplementation was seen among women who had the lowest education as a broad marker of possibly low level at baseline. So again, we were able to find there is a benefit of prenatal folate supplementation. The risk was also, in our study in California, the benefit was much higher among Latino women. So if they do not receive prenatal vitamin, they will be at much higher risk of having a child with leukemia. We also wanted to look at the diet more holistically because, again, you cannot just take out one piece, not looking at the overall quality of the diet. And we adapted our food frequency questionnaire to a healthy eating index that was developed back in 2010, not specifically to look at cancer, to look at other outcomes. So using our own data, we were able to develop this index, and what we find is that whether we looked at the data in a continuous fashion or we cut our data in quartile, we found that there was a reduction in risk when the mother had a healthy diet during pregnancy and even before pregnancy. And that the risk was definitely, much smaller as the diet was healthier. So those are kind of very important, information we can get. Genetic studies, I think, are still in the infancy, I would say, for us. We went from very limited candidate gene information to genome-wide association studies. I think none of them have been necessarily satisfactory to answer the question, does the environment and genetic background is the very potent mixture to increase leukemia. But I think we are going to be there because of the richness of the data we generate from the genome-wide association study. We can pick that up again and do some G by E analysis or do some pathway analysis and to really target our investigation and not go necessarily from agnostic, but from SEMA-agnostic, I would say.
Going to have to break for lunch. Can we have your final slide?
Yes, I am. For the future, I know you're interested in that. Okay. So I'm going to go over that quickly.
Very quickly, yeah.
Yes, I think that, as I said, population-based studies are really important. We should continue doing them. We should integrate a lot of method studies to strengthen our findings. The linkage design, I think that, Roberta mentioned that working with linkage studies will help to also work with such a rare disease. I don't think we have done a good job yet at incorporating biomarkers of exposure and the disease. In our group, we are doing this. I don't have data to show you yet, but I think that's going to be a good complement to what has been, found in the previous analysis that we've done. I think we should focus on highly exposed population. This is where we're going to know the best. What we have not done well is looking at cumulative impact of all those different mixture of exposure, and we talked about that. And what I would like to do moving forward is actually look at the impact of the environment in cancer survivors. I think that group of patients has been completely ignored in terms of what is the impact of all those agents, not only in etiology, but how well they do once they survive their cancer.
Yeah. Okay.
Thank
Thank you
you
very, very much indeed.